OBS in all its wisdom forgot my audio device. And I'm late. But, hey! Oh man, I'm running late. It's okay. Let's see here. How is the audio levels? If I don't touch the microphone, it seems okay. And when I don't speak, there's a little bit of music. That sounds okay too. I still need to mute my phone. Oh, and I didn't turn on the back wall. Oh no. There we go. Back wall on. And now we need to, you know, set something fun there. Let's choose an effect together. What are we going to do today? We're going to do fireworks. And then we're going to do fireworks in random colors. Sure, that's nice. And I still need to fix the background colors that they rotate. Hold on just a second. Okay, that's working too. And now I can pay attention to chat. Hey guys! Oh, there's been lots of chat. Oh, the red circle again. Yeah, Philip saw the red circle before. Ordering reversible diodes. Well, that's certainly the issue. No pre-stream party. Yeah, sorry, I was running too late and then my camera wasn't working and for some reason the battery's dead, but I have multiple batteries and I'm charging an extra one and, you know. I didn't spill the Coke this time. No, no, no. Aw, Johnny has to leave again. Aw. We might need to mod that Quinled character. Yeah, I get that. So, well, I need to relax a little bit before we actually start the content. That's why I like to do the pre-stream stuff. We have normal Coke today and we have vanilla Coke today. I'm going to start with the normal Coke because, you know, I want some. Oh, there's a question here. Brandon might. So, first question of the day. Sure, let's have it be the first question of the day. I haven't touched WLED software yet. How does a dig quad treat multiple strips with each data output? It treats it any way you want it to. It can treat multiple outputs as a single strip. So let's say you have 300 on LED 1 and 300 on LED 2 and 300 on LED 3. You can have it act like that's one giant strip and thus a strip of 900 bridging the outputs perfectly. Or you could say, okay, I want segments and I want LED 1 and 2 to be one strip and then LED 3, everything that's behind there, I want that to be another segment doing a different effect or whatever. You can configure all of that, no problem. Need some vodka in that Coke. Cuba Libre. Any magic smoke? Well, we might actually see some magic smoke today. There will be some smoke. Let's hope it's not magic, but we'll see. Two questions. Is there a max cable length between your new board and the LED strip? Basically, it has the same level shifted circuit as a Dig Uno or Dig Quad. So generally, I say 10 meters to 32 feet should work in generic conditions. Anything beyond that can get kind of sketchy. 10 meters is already kind of sketchy, but because of a very precise level shifter and resistor selection and stuff like that and circuit layout, it generally reaches that no issue. But beyond that, you kind of want to look at differential signaling. So basically, the new brain board will be the same as a Dig Uno or a Dig Quad in that regard. Will you drink Pepsi? I normally don't but recently tried Pepsi Nitro is amazing. I don't have anything against Pepsi. I don't like Pepsi Coke, but other than that, Pepsi has some other brands I like. I haven't heard of Pepsi Nitro yet, though. Quindor did one live stream with the Dark Side Coke. So I was going to do a live stream about something completely different today. Well, it was also about PCBs. But I got a giant box from AllNet today. And it has my pre-production samples of, well, the Dig Octa system. And I need to move some stuff out of the way here. If I can. Yep, I can. Hold on. This is dangerous. There's live Coke here. Okay. Good. So, this box has some very interesting goodies, because it has everything from the Dig Octa system in a more final-ish form. But, well, the title of the stream was already, they effed it up during assembly, which they did. But we're going to take a look at the Dig Octa system a little bit more. That's also the secret of the day, because the whole stream is just a secret. And then we're going to try and fix what they effed up and see if we can make it work so we can still do our testing on these boards instead of having to wait like a month again to do a new production run and spend another few $1,000s doing that. Right. So, who here caught the announcement of the Dig Octa system last time, or as a secret? There will be videos coming out in the coming 2 weeks or so, all about the system and details and things like that. But hey, you guys are here in the live stream, so you get first showing. Let me see if I can go to that camera. Oh, it actually works. How nice. Right, so Dig Octa. If you caught the last live stream, this might be a bit double, but basically it's a system where there is a brain board and a power board. The brain board does everything from connectivity to network or wireless, USB-C, and it has 8 LED output channels, fully level shifted and switchable resistor, etc. And then there are power boards which do the power stuff. So it's a system that's meant to scale whatever resource you need independently. You need more LED outputs? Okay, get more brain boards, and they're meant to stack on top of each other. Need more power handling or power outputs? Okay, get more power boards and stack those together, and these two also stack together. So it's all meant to stack together so you can build whatever controller you need. Oh yeah, no, this board is a beast. This is the Power 7 HC. I can't wait to start testing this production sample. But this board is heavy. It's just, holy shit. There's so much copper in here. It's insane. But I received these a few hours ago and I haven't turned them on yet. So I was like, okay, let's involve my community, and since I outed the system already, let's, involve them a little bit in the testing. And, well, this is the Power 5, and there is a slight issue on here. And, well, that's going to be the bulk of the live stream, so let's start showing you that, and then maybe we'll build a stack before we start soldering and test that out. So, hold on just a second. Right, so this is a Power 5, and, well, it says it right here, I think, Power Board 5, yes, version 1, release 0, because this is pre-production. And, I need more light. Where is my Home Assistant? It's over here. Let's go. There we go. That should be fine. So, there is some diodes on here, and I need to see if I can make the light catch them perfectly. Let me remove some fuses here. They're blocking the light. Still not enough light, hey? Let me up everything even more. Let's go to skylight, turn that on, and give this even more brightness. Okay, that will can't really do more than that. Anyway, on this sample, if you look closely, and if we can focus, the stripe is on the right side of the diodes. Right? Right. But if we take a look at a render of what it should look like, and I have to look that up. 1 second, please. Board shots. So let me add a window capture. Interesting. Transform, reset. It's not showing anything. Why is this not working? Okay. I'll open in here. Sorry, this is the best prepared stream I've ever done. Can I show this window? There we go. If we look at my render here, and I hope I can zoom in, there we go. You can see that the stripes are on the left side, but on the actual board they produced, they're on the right side, which isn't the correct side. So that means now each of these diodes is directly shorting out the fuse. That's not good. That's certainly not how I meant it to work. Chat's gone. There we go. So I already knew this was a problem. We actually figured that out with my guys in China from Allnet. While it was already shipped to me, this pre-production batch is for me to test everything with the production parameters and the production components, and discover what we encounter during production, so that instead, when we make 500 or 1,000, all the problems that these boards have will already be solved. But of course, there's now 25 of these boards that have this issue. Now, these will also go out to, beta testers in that sense. Some people from my Discord and others involved in the LED community. And those will be fixed. They're currently being fixed by the assembly company because they just did something stupid. They even have my renders on how it's supposed to work. So they're fixing that now. Sadly, that means I can't ship this week, but beginning of next week to my testers. But still, the idea is to introduce or have the system for sale somewhere around the end of September. And by then, testing has been done and full production has been done, and there will be plenty of stock in Allnet and Dr. Z's of all various components, so you can, build your LED setups with that. So, for now, what I want to do today, what I think is fun to start off with, as I said, I haven't turned anything of this on yet. So let's build a stack with a board. I do know that works. End of September is Johnny Bergdahl's birthday. Nice. So let's, build a little stack with a board that should work. And then continue on trying to fix that other board, because it's very hard to get those components, because this is real life size. They're literally in between these fuse sockets, so I have to figure out how I can get those desoldered while there's leadless solder on there and stuff like that. Ballpark pricing has not yet been announced. I have kind of mostly figured that out by now. So I'll keep that as the secret of the stream. I'll do that at the end of the stream. Sorry, Klaus, you'll have to wait. Remind me at the end of the stream that is the secret of today. Yeah, Killer Geek, that is actually my idea. Remember that 20 centimeter by 20 centimeter hot plate I got a while ago? Well, that wasn't for nothing, because I was building these prototypes, and these are bigger than 10 by 10 centimeters. So, we'll probably be heating up this board, the Power 5, to 100 degrees, and then using hot air to try and get them off or turned around, and then, see if we can do that without melting everything else. But, yeah, we'll see. We'll see. There is a screen print error on the PCB. You already saw this? Where? Where, Adam? You can... Okay, you can speculate on price, but I'm not going to answer until the end of the stream, okay? Where is there an error on the Power 5? It's going to be less than $70 for a single component. It says max fuse 0 amps by the fuses. Where does it say that? 10, 10, 10, 10. 10, 10, 10, 10, 10, 10. Oh, there's a smudge. No. There's a smudge there. Over here, there's a little smudge. I removed it. Yeah, so, no, it says 10. It says 10. Why is it so dark? Let's see. Can I do it like that? I guess that's better. Is that better? Less dark? Okay, now it's a bit... How are you doing? There we go. So, there are still some issues here, but not that one. This is the Dig Octa system, and this is a Power 5, which we're going to fix later. So, right now, we're going to take one of these, and this is a brain board with ESP32 on there, Ethernet, SD card slot, 8 outputs, temperature sensor, button inputs, I2C, everything together. There's also a nice silk screen on the back. And, well, in theory, this one should just work. So let's just power that up and give it Ethernet and see if it comes online. And I'm not sure if this one has already been pre-flashed or not. We're going to find out. And otherwise we'll flash it together. So, this is a tight Ethernet socket. What's going on here? Oh, okay, that's a snug fit. Let's power it up. Okay. Yep. Oh, nice. Oh, okay, well, this one's pre-flashed. So Ethernet comes up right away. And, well... we can talk about a few of the features. I already scripted out a video, but, So if you look at the board, I'll zoom you in again. You see, let's talk about the LEDs. First off, you see a green LED here, and that means that whatever is coming in is being made into 5.12 volts of power. So officially, the board is 5 volt to 24 volt compatible. But because of a redesigned circuit on there, it'll actually take in 3 volt to 24 volts and always make it 5.12 volts, even if it's 3 volts. So where the Dig Quad, if you drop below 4.3 volts, would become an issue, this can go even lower because I redesigned the circuit a little bit. and always provide a stable output voltage. So that's this green LED over here. Then we have an orange LED here, an orange LED here, and an orange LED here. So 3 orange LEDs. That is for the 3.3 volt regulators that are on the board. So instead of using one regulator for everything, the ESP32 gets its own regulator over here. The Ethernet circuit gets its own regulator over there. And then the SD card slot and some other things gets its own regulator over here. And each of those orange LEDs corresponds to that. So this jumper, for instance, is the power enable pin for the regulator for the Ethernet. If I pull that off, you see the Ethernet port turns off. And that means that if you don't need Ethernet, you can actually fully disable everything that has to do with that circuit to minimize on power usage. Let's turn it back on again. Don't think Ethernet... Oh, it actually comes back. That's not bad. Okay, so that's the LED. Oh, and we have a blue LED here, which I think is a bit too bright. I'll have to dim that down. But that is actually if the relay output is enabled or not. So that'll switch with the relay. In theory, because I haven't tested that yet. That's new since my last prototype. Oh yeah, Killer Geek already noticed the blue one is too bright. Yeah. But that's why this is a pre-production batch, because I use the LEDs I have in my boxes here, but in China it's possible they use, or well, not in China. Allnet is allowed to use substitute parts for the LEDs because they don't have the exact same part number I have. On some stuff they do, because then it's important, but for an LED, I just want an orange LED, and I don't really care what brand or vendor it's from. But then sometimes the resistor value might need to be adjusted because it's a different type of LED than I had over here. But that's what we do. That's why this is pre-production. Sometimes pre-production doesn't work at all, and that means we need to do more, development. In this case, everything should work, including the Power 5, but the assembly company screwed that up. So next to me making something that doesn't work, even if I make something that works, doesn't mean the assembly company will put it together right, basically. Even though they have the renders and files and positioning and everything I prepare, they still can put on diodes in reverse. Which really sucks. But that's why we do... I spent thousands on this pre-production batch just to make sure that when I do the production batch, which isn't like 20 boards, but is 1,000 boards to get the cost down. This board with like 20 boards is $80 a piece. This guy, one of the power boards is like $100 or $250 a piece. Just because the quantities are so low. I have to scale it up massively to get it to prices where it's sellable. But once I do that, I have to make damn sure there's no issues during production. So, how do you fix the ground shared? What do you mean, Leon? I kind of got on a ramble there and forgot chat. Also, OCD triggered component placement. What's wrong with my component placement? It's all where it's supposed to be. I think it looks really nice with white. That's why this board isn't blue. It's white because blue means the board also does power. So now we have black and white boards. Black for power, white for other things. I forgot to put the antenna on, that's correct. But in theory, because the Ethernet is on and the Wi-Fi isn't connected, it should go into Wi-Fi sleep mode. And I've ran a ESP32 without an antenna with Wi-Fi sleep mode on for weeks and months now, and so far it hasn't caused an issue. But yeah. How much does this board draw max? Well, I haven't measured the max yet. The DC-DC circuit can handle more than on the DIG Uno and Quad. So I now rate it at 750 milliamps, output at 3.3 volts. But currently with Ethernet on, it's using 350 milliamps. So what is that? 1.8 watts. But that's with 4.7 volts coming in because my PC USB port isn't that great. There's a long cable on there and, you know. So generally it'll use 250 to 300 milliamps. That's without a relay. If you add a relay, it'll use more. Anyway, I got sidetracked because we were going to build a stack. Oh, wait, I was testing if the board worked. This seems to work. So that's good. That's good. I'm very happy with that working because I didn't know if that was going to work. This is really the first time. The box is right there. You can't see it. This is literally the first time I've turned these boards on that are fresh from production. And these are the first versions that I didn't build myself personally. So, well-prepared stream script again. What? The Pee-wee questions. Yeah, I'll have Pee-wee answers in the future. Anyway, I need to get something from that box. Because in theory, the material to stack it is also included. So let's see here. Whoa. There's a giant bag of pluggable terminals. Hello, I'm here. Focus. Okay. Of pluggable terminals and standoffs and screws and I don't know what. That's what we need. Nice. Yeah, lots of goodies in this board bag. Or box. Anyway. Let me try and get what we need to stack the brain board on a Power 7. And then we'll just turn it on and see what happens. So we'll need some plugs. And I think this is a little baggie for the brain board. Because it has 4-point pluggable terminals and one orange. Which is for this one here. That's to power the board if you're not using the stacking feature or USB-C. So there's 3 ways to power the board, but we need that one. We don't need this. I need to see if this is M2.5 or M3. Sorry. The LEDs worked and the Ethernet was blinking. And if the Ethernet blinks, that's often a good sign. Okay, this doesn't fit. So this is not the bag I'm looking for. Because this is a bag for a power board. Then it's likely this one. Yes, okay. Now, as I said, I'm doing this for the first time with these versions of boards too. So, grant me a little bit of slack here. We want to raise this board off the surface because there's all kinds of contacts on the back. This is yeah, okay. Now that we're talking production issues anyway. So this is a Power 7. And as you can see, I have some islands here to carry the current. And what they should do, which they did on the Power 5, is that they flood those islands with tin. But on the Power 7s, for some reason, the production didn't do that. So, well, that's another one of the things we need to tell production to do differently. So that once you guys get the boards, this is all done correctly. Okay, first thing is I want to raise the power board off the ground. And for that, we include some standoffs that are short. And some screws. And the idea is that, how am I going to, okay, probably just going to do it like that. Need to get a screwdriver. So are these magnetic? Yes. Okay, so the easiest way to do that is likely to put the screw through, and then thread the standoff on, and then just screw it together. Most of this is automated, Yoko. I would buy a PoE version with onboard relay for the PSU. Well, the brainboard has a dedicated relay, so the power boards don't get a relay, or relay output, sorry. They don't have a relay. But they do have a dedicated and strong relay output circuit. But I have plans for PoE, not for LEDs, but for standby power. But that's a future endeavor. Okay, so now our power board is raised off from the surface. You can really tell by the board not flexing. There's a lot of copper in here. Okay, next we need to put in the standoffs to add the brain board on top of the power board. Right? And the lengths of these posts are not finalized yet, so keep that in mind. We're going to do that the same way, and for that we're going to be using the posts that can get a screw on both sides. So there's posts that have a screw on the top, and there's posts that don't have a screw on the top. If you're only putting on one board, you take the posts that don't have a screw on top. If you're putting on multiple boards, you take the post that has a screw on top and you screw that with a screw into the board. And then you can stack on another one if you want another brain board. And I can already tell you, these are too long, but we'll make it work. So, same deal. Put the screw through. Oh, I missed it. I need to find a better way to do this. But put the screw through, screw it into the standoff, it'll line out, and there we go. So these boards feature something that I call Q power post, and that means that a power board can actually power a brain board that's stacked on top of it. For that we have 5 posts, 4 which are on the sides are ground, and this one in the middle carries positive, so power. But it's very well protected, and even if you completely dead short it on something, that's no problem. The worst that can happen is that it doesn't work. Nothing's going to blow, nothing's going to break. And there's all kinds of provisions to prevent backfeeding of power and things like that. No, in this, well, you can use PVC posts if you want to. But then, hold on, I need to see what I'm doing here for a minute. You can use PVC posts if you want to, but then you just won't have the power transfer feature. But if you take a close look here, there's an orange plug here on the power board, and there's an orange plug here on the brain board. And that is meant for if you don't want to use the stacking feature. All the power boards have a dedicated output that is again protected against backfeed and has a fuse on it, etc. To power a brain board if you want to do it that way. Okay. Now, this can go on this way, which is the intended way, as you can probably tell by the cutout. Or you can actually put it on this way. Or you can put it on this way if you really wanted to. Or this way. And it'll never cause an issue. It'll always work. Now, something is higher than the other. Or the board is bent. Is the board bent? Yeah, the board is bent. See that? It's wiggling. Interesting. Why did that happen? Huh. Well, we're going to see. Because it's not lying flat. But we are going to screw it in. So we'll see what happens there. Let's not tighten it completely yet. Okay, it's too bright. It's too bright. So the max fuse is 25 amps, but the max recommended current per input is 20 amps. And then there is a third rating, and that's the max current of the board, and that is 50 amps. So, I mean, those are three values that are linked to each other, but don't necessarily have to correspond the same to each thing, because the 25 amps has to do with the fuse socket and the input socket and a little bit with the wire you're attaching to it. But then the 20 amps has to do with how I recommend you split the power, basically. And then the max total board has to do with all of those things, and also the copper that is on the board and the amount of power distribution it can do, etc. So there's multiple values that come into play there, and that's why those values at first glance might not seem logical. Why do you allow 25 amps for the fuse? Well, that's because it only blows at 25 amps and not at 20 amps, which you're allowed to use it at, because then it wouldn't make sense. It's from remotely launching the missiles, yes. Okay, well, it went on without any stress, and that looks fine. Yeah. So the idea behind the size of the board is that I can still reach these fuses and these fuses. There's actually fuse indicator lights over here and over here for each output, that if you have a broken fuse, it'll show that. And there's going to be a voltage meter here, but those weren't ready to ship yet. So each power board will have a voltage meter on there, so you can see voltage drop incoming to the board and stuff like that. And, well, we can still reach the power input cables to, add our cables. And even if we really wanted to, we could still reach these fuses over here. Now, it's very unlikely those are going to blow unless you have a cascading power input failure, basically. So, yes, those are a bit hard to reach. But in theory, you should never have to replace those. And these are the outputs, and that something happens to the outputs is much more likely than the inputs. The reason to have input fuses, though, is because I allow 3 wires to go to the same power supply. And if you wouldn't have fuses on the input, if you'd have a major imbalance, or for instance, you think you have 3 cables connected, but it's only 1, you can massively overdraw that cable and still create a dangerous situation. But now with a fuse per input, in theory, those dangerous situations are mitigated also. Okay, but yeah, that was the whole process of adding little feet to the power board, screwing in the standoffs for the brain board, and then just screwing in the brain board. That wasn't that hard, I think. I think people can figure out how that works. There's no pre-order right now, John, but I might do some, I might not, because of the previous boards. I basically have the cash to upfront this. So I don't like making people pay for something that isn't there yet. That's why I don't do Kickstarters or other crowdfunding campaigns or pre-orders or things like that, because if I can pay for it myself, I don't need you to give me cash for something that doesn't exist yet. Because I don't know. It doesn't feel right or something. I'm a bit difficult like that. Okay. I have my bench power supply here. I guess we can use that. I need to turn it a little bit. Okay. So, board input is always on the right, same as on the Dig Uno. So this is ground, this is plus. You can't really see it, but there's a big plus here. And I've already ground on my boards are always surrounded by white, as you can see here, ground. And well, you can see here that those terminals also are surrounded by white, and they have ground or ground written there. And something that didn't make it into this revision, but the actual production will have, it'll also say ground here and have the plus symbols here. See you later, Johnny. Good luck in the bars and have fun. So let's hook up ground. There we go. And look, let's hook up positive. And we're just going to do a quick test to see if we can get LED output, and you know that works. Then I'm really happy. And we can move on to trying to fix that power 5. Okay. Let's get power to my bench supply. Oh god, where is this connector? Oh, I think it's this one. Okay. My office is becoming too small for all the things I have here. Okay, in theory, it should turn this guy on. I hear the click. That's good. Yes, it does. Okay, nice. You can't see the power supply right now, but I'm setting it to 5 volts. And let's set the amps to 1. Because I haven't tried to turn on this power board yet. And in the case, when testing something, it's good to not hook up a 100 amp power supply immediately, but give it like 5 volt and 1 amp or half an amp and see if it explodes. So I guess I should wear my my glasses, huh? Hold on. There we go. Let's see if it explodes. On. Nope. Seems fine. So there's a little power LED here for displaying that the power board has power. And we can also see that the stacking feature is working. I guess I can take this off again. Because, well, the board lit up. We have 5 volt and we have our 3.3 volts everywhere. And the relay turned on. Let's put in Ethernet. Yep, that works. Cool. Now, okay. If that's all working, let's see what IP I got. And let's open that. And I'm going to try and show you guys. Okay, hold on just a second. There, we have WLED, which is too big. Oh no. And just to show, this is the Ethernet one. Yeah, we're at 100%, so that's Ethernet enabled for sure. Okay, that seems to work. It's drawing 350 milliamp-ish, so it's not drawing the full amp it's allowed to draw. That's good too, so let's turn that off again. And, I don't know, attach some LEDs. And then this first test will be done. So let's take one of my LED load bars, which I made very many live streams ago. And well, the design of the power board basically follows the rules of the input. This, you can't see that. This side is positive, this side is negative. So that means these are all positive on the power 7. The power 5 works differently. I'll show you that later. And these are all negative. So let's take our, I don't know, let's hook it up over here. Okay. These terminals will take up to 12 gauge with a ferrule. Now these power 7 boards should be fine. The only issue is that it had a manufacturing issue on the power 5, which we're going to try and correct ourselves. Okay, so now it has positive on this side, negative on that side, and we need data. Oh, and we don't have any pluggable connectors here, but we got this little baggie. How many inputs is that? Inputs, you mean data or power or? Okay, so we're gonna put this one in here, and okay, we need a smaller screwdriver for that, but this one should do, because I custom ordered these 3.81 millimeter pluggable connectors with screw or Phillips heads instead of the normal flat heads, because I don't know, I hate flathead screwdrivers. So everything here has Phillips heads. So even the terminals, these guys, these, etc. But those are custom order, so we had to order a few thousands of them. But, you know, I want my Phillips heads, so... But Michael, what output side do you mean? The board has 8 LED outputs over here, 2 times 4, and this power board has 16 positive and 16 negative terminals. So, okay. Everything lying in the drawers are flathead. Oh, yeah. Already suggested to throw them away, they don't want to. Okay, so let's set the amps to something higher, because that worked fine. Let's set it to 5 amps. We have positive, we have negative, we have data, power on. Okay. Oh, right. Okay, sorry, you can't see the bar. So, the bar is displaying all kinds of random colors. I was like, uh-oh, something's not working. But it's set to 8 outputs of 30 WS2812Bs, and these are SK6812, so RGBW. So that is actually correct. So if we go into WLED, LED preferences, everything here is auto-filled in because I use a pre-compiled version that has all of that set. We're in LED 1, so let's change that from W2812 to SK6812. Save, and there we go. It's nice and orange. Let's do some more. Let's turn the brightness limiter off, and let's give it 144 LEDs. Okay, it got brighter. Yeah, we can turn it down. We can change colors. Nice. Okay, let's see if we can do more. I don't know, color twinkles? Yeah, that's working. Cool. So, first tests of these pre-production brain boards, at least, seems to be pretty good. We've got Ethernet. because, you know, Wi-Fi certainly isn't connected. There's no antenna in there. We have an LED output. I'll test the others later. You know, there's lots of more testing to do. Yeah. Oh, right. And one of the things I wanted to test. Nice. See that blue LED turn off? So power is off in WLED, and if I power on, it turns on the relay, so this LED turns on, because that's connected to the relay pin. That works great too. Cool. I haven't tested that yet. This board does not do pink, correct? Oh, correct! No, well, it can do pink if you want to. There's some pink in there. I mean... How does the data board get power? The data board actually gets power through the standoffs. So that's why if you have a power board, you don't need to power the data boards separately. And you can even stack them with multiple on top of each other, and they'll all receive power. Even better, because of all the custom circuits, etc. in there, if you wanted to have multiple power boards, you can even have multiple power boards of different types in the same stack running different voltages. So say you want to have 2 brain boards, and you want to have a power board for 5 volt and a power board for 12 volt, you can run all of that in the same stack without issue. Oh, you're opposite. You like the flat heads better. Okay. So, I mean, I get there's a slight risk in having power run through posts, but it's up to the wazoo with protections on there. So, I don't know what you could do to make it fail, basically. Of course, somebody will try to think of something I didn't think of, but, you know. Cool. Well, that works. So, I was just too curious about that before I started soldering and things like that to see if something actually worked. You can mount it on a metal plate if you want. I tested that, Emil Bart. The worst thing that will happen is that it just doesn't work, because the positive output will just shut off. Yeah, it's a new LED controller I've been developing since last year. And, well, we're talking about it now, and it'll be available pretty soon. It's not ready quite yet. This is a pre-production version. But, yeah, that all seems to be working great. Lighthouse. Yeah. Cool. Everything is marked. Only the middle one is positive. The rest are all ground. Oh, did we get 2 types of screws? No. Cool. And I mean, it's on there. It's not fragile in any way, because if power would have been interrupted, this would have crashed, but this is still working just fine, so. Yeah, if you connect it to high voltage, but even then, the brain board will take up to 24 volts, and anything between 3 and 24 volts, you can wildly change, no problems there. Oh, Savaga's here. Hey there. So, yeah, anyway, I guess we did some of the secrets first now. But that seems to be working great. It's looking great, at least in my opinion. And, yeah, you can even, you know, fold the cables like that. And if you need to reach the fuses, you just pull that one out, get the fuse that you need, and then plug it back in. Oh, we could actually test that. And then we'll actually move towards fixing the... Wait, did it? Oh, I was going to say, did it continue the LEDs? That was odd. But no, just plug it back in. That works. We can actually test to see if a fuse failed. And I need to get the pliers for that. by just yanking the fuse out. There we go. And now we have a red light on the socket where the fuse failed. But if I pull out another one, nothing happens. So it'll only show the broken fuse light if there's actually something connected to that terminal. If you only want to populate half of the fuses for whatever reason, you can do that because the failed fuse light will only light up to a port that actually has something connected. And there's even a special circuit in there which makes sure that the broken fuse light is the same brightness, whatever voltage is coming in. So, yeah. Fancy, right? Well, that's something my other boards don't have. So this, in that sense, is a step up. Well, in a lot of senses, I guess. So let's reconnect that. And immediately the LEDs work again. Cool. So that is working too. See, I'm already testing this board while you're still here. But so far it's working great. At least everything that I built in there seems to be working. This really old fuse feature you haven't seen in years. Yeah, but, I mean, it's useful. Because if you now pop a fuse, we don't have to ask everyone in the Discord, did you check if the fuse broke? Because there's a red light exactly at the fuse that broke. Philip, there was supposed to be a shipment to the US this week, but it slipped to next week. So at the end of next week, Dr. Z's in the US will have plenty of stock for most of the types again. I'm not sure about separate ESP32s though. That's generally worldwide only. And since we were running low, we might not be have stock for the separate ones, only the bundled ones. These are indeed brass standoffs. If you use other types, that could potentially be an issue, but they will be delivered with the boards. So you'll get an assortment together with the power boards, and you'll get an assortment together with the brain boards, so that you can always build the appropriate stack. But what if the LED does not light? What LED? Killer Geek? What do you mean? If the fuse LED doesn't light while you have something connected and have a broken fuse, well then I did something wrong or that part is broken. But the chances of that are pretty low. But hey, at least I put on the LEDs in the right order. The right way. Okay, let's turn this off. Let's unscrew it. And let's get to trying to fix the Power 5. Because that's going to be interesting. If I can actually do that or not. Okay. But I just got these in. I had the patience to wait until all of you guys were here. I just didn't have the patience to wait anymore while you guys were here. But this is looking very nicely for, you know, the first part of the pre-production. Because who knows, maybe all of these came out broken. You know, it's happened before. Yeah. Okay. So, let's get all of this out of the way for a little bit. I'll put this on here. Okay. Right. So here we have the... did I use this? Yes. The Power 5, which is a different board in the sense that if I get a Power 5 board, baggy here, this does not have screw terminals. This has pluggable connectors you can plug in like that. And this also has plus and minus combined on each plug, instead of on this board you have all the positives here and you have all the negatives here. On the Power 5, each plug has a positive and negative. So it's a different approach on doing things, and especially if you're stacking multiple of these, this guy has all the ports on the side, so in that sense it's a lot more interesting to stack. Sure, there are many versions of those fuses, Barry, but in my testing, those also have different properties, like dealing worse with the heat. And why am I plugging these in? I need to take them out. So if you're only using 5 amp fuses, those tiny fuses might, Jesus, it's certainly in there. Those tiny fuses might work okay for you. But in my testing, the bigger ones are better at handling high currents, so 10 amps for instance, than the smaller ones. And that's why I like to stick with the big ones. Also, even if I went for the smaller ones, it wouldn't really make the board any smaller. So, yeah. This is for power distribution only. That's correct, Nicholas. Sure, Jordy, but that's why there's multiple boards. You can build your LED controller whatever way you want to. So let me get the rest of those fuses out. Oh, Andy's here! Adam, there will be versions of this board. This board has actually been fully prepared for the use of PTCs. Actually, let me show you. Here are some prototype boards. This is the same Power 5 as you see below there, but then with PTC fuses. So I have been doing testing on that already. And this is a Power 7 with PTC fuses. So yes, likely in the future I will release a version that has PTCs on there. I'm not sure those will be available for the general public, but at least for installers and things like that, I can imagine them wanting PTCs instead of one-time fuses. So I'll likely make versions or runs of that for installers and things like that. Hey, Roller's here. Nice. Yes, I also know the resettable fuses that go into these sockets, but in my experience, their specifications are wildly varying and will likely allow way too much current and blow too slowly, etc. I've had bad experience with those. Hey, DJ Roscoe. Well, if you look carefully, though, it is on there. I mean, it says max in 20 amps, max fuse 25 amps. That is because you're actually allowed to do 20 amps per input as long as the total stays below 50 amps. And that is kind of to force you to use multiple cables from your power supply. Because if you're going to use up to 20 amps, I guess you could hook up just one cable, but if you then want to use more, you'll at least need 2, and preferably 3, like the Meanwell LRS series has. So, yeah. No, there's no notice. There's no circuit that measures if an output is actually outputting. So there's no way to get a notification if a fuse fails. Sorry, no. But yeah, it just shows you a light. The Power 5 also has a light, but those are actually right next to each socket, so that you can see those from the side. Again, when it's stacked, the Power 7 in that sense, and well, I guess I can show you this guy. The Power 7 HC, which is the high current version, that's this guy. Those are less suited to be stacked. They can still be stacked, but then if a fuse blows, it's going to be harder to see because you can't really see it from the top because it's stacked, and you also can't see it from the side because there's a big terminal in the way. So it depends on the use you have. But, you know, if you have only the requirement for 16 outputs and then 2 brain boards on top to have 16 LED channels, for instance, then it's fine using it that way. So yeah. So this is a high current version of the Power 7. No, that's not here, Philip. So this is the Power 7, you know, with the input terminals and input fuses and things like that. And then there's a Power 7 HC, which stands for high current. The normal power boards are suitable for up to 50 amps continuous. The high current version is suitable for up to 100 amps continuous. Did you trademark Q Power Post already? Yeah, this is upside down. Yeah. So, yeah, anyway, we're going to work on this guy. How am I going to do this? Because those pesky little diodes here, they're on each output, need to be reversed. So what I'm thinking, and Killer Geek already hinted to that, which was a good thing, is let me get my big heat plate. So this guy. I am really proud of these boards. There was a lot of work that went into them. So, yeah. And so far, because these are the final tests, basically, everything seems to be testing fine, except that assembly screwed up and messed up my... What is so high? Well, I guess everything is so high. Okay. They messed up my diode placements on these. So let me give you a tighter shot. But I also need to be able to see well myself. Let's move it to the side of the heat plate, because then I have an easier working surface. Okay, what I'm going to do, is I'm going to power on the heat plate and tell it to go up to 100 degrees. Hold on. Now these are pre-production Tech Turtle, and that wasn't ready yet. The production versions will have that feature. So, Barry, it's actually an interesting conundrum. Oh, let me turn on this heat plate first. Hold on. Yep, okay, it's set to 180. Let's go down. Just 1 second. Set. Because I don't want everything on the boards to melt. I just want the board to be warm so that I can hit it with the heat gun and then turn around the diodes. That's the idea. So the reason there's no... something fell down. Okay. there's no lights on the input fuses is because that's a lot harder to detect. Because let's say you have a cable in this guy and then it goes through this fuse. If this fuse blows, how do we detect that? Because the power will still be here. There won't be any power outputted here, but these two do still output power. So if I measure if there's power here, which there isn't coming through this fuse, it'll still be there through these fuses. So it's not easy to figure out if that fuse has blown. While on the output side, that is. Yeah, that's correct, Wayland. Okay, let me turn on some more stuff. No, not that one. Okay. And let me turn this down. Okay. Well, yeah, Emil, that is true. But then getting a diode that does 25 amps adds extra resistance and heat and all kinds of problems. Okay, so the heat plate is already at 79 degrees. Okay. A little while. Yeah, no, these are my pre-production boards. So now I can figure out what went wrong in production, like these diodes, and make final adjustments before we do a big production run, because if the problems only pop up during the big production run and we have to change something on all of the boards, well, it's a lot cheaper doing that on 20 boards than on 1,000 boards, basically. Just one component is placed at an angle. Which one? Oh, you mean my PTC here? Yeah, it happened to work out that way. You see the problem. There's not enough ESP32 Ethernet boards available. We did run out because we've been waiting for months on the Ethernet chips, but we got those now, so they are being produced. So there's still bundled versions available, and the separate versions should be available relatively soon. Now I really wonder if we'll be able to get to these diodes and move them around. It's going to be tedious, especially like this one over here. Oh man. I'm going to try and turn them around and then solidify them with the solder that's there, but it's going to be tough. So the heat plate is at 97 degrees, but like Philip already mentioned, this isn't sitting flat on the heat plate because there's all kinds of pins sticking out on the bottom, but heat will soak up through those pins to the PCB, but it's going to take a little while. Oh, actually, I think I have my my thermal camera phone here. Does it still have a charge? 14%. Good enough. I think so too, Philip. I'm not going to put money on that. Okay, let's see with my thermal camera phone. Oh, I have to keep it that way. I guess I can focus on that. Oh, there we go. Okay, so the board is currently, I have to angle it in a nasty way, about 50 degrees on the sides and about 30 something in the middle. Yeah, makes sense. So let's give it a little bit more. Those input fuses, I don't get it. You're not allowed to put in more than 20 amps. Why fuse it at 25 amps? Because you're allowed to run it at 20 amps. And a 20 amp fuse running at 20 amps will get really hot because it's almost on its tipping point. So that is too little tolerance. So you always want a fuse that is slightly higher than the load you're expecting. So if you're expecting to run 20 amps, you should have a 25 amp fuse. And that is exactly the case on this board. You're allowed to run up to 20 amps per input terminal, and thus we have a 25 amp fuse. Now, these input terminals are... Oh, we don't have focus. These input terminals are rated for 30 amps each, so that is still well below what is rated for the terminal. And if you follow the guidelines of connecting a 10 to 12 gauge cable, 25 amps for a short input cable will also be fine for those cable sizes. So the whole chain in that sense makes sense, in my opinion at least. I plan to stick with the heat plate and on 100 degrees, as it is currently. And in theory, that shouldn't melt anything, because those fuse holders can easily become warmer than 100 degrees. I believe these terminals are also rated for about 200. These fuses can become more than 100 degrees for sure. And the rest, well, they also become that during soldering. So, yeah. I have not yet, Dr. Roscoe, but my experience so far is it's okay. I like my FLIR better because it has better software, but for what it is, it's certainly not bad. And it's still cheaper than a FLIR, and you get a phone to come with it, which is actually a pretty decent device with a massive battery. So, in overall, I like it. As just an IR thing, I think FLIR is better. But it's, it's not bad. I'm going to hit it with hot air, Andy. Because I think I'll have a very hard time getting my my iron in between here. So I'm thinking of hitting it with hot air. Just long enough so that I can turn the diodes around. And then melting it again with its own solder. Yeah, it's to preheat the board, yeah. So I don't have to hit it for like a minute to get to the temperature where the solder melts. Hopefully I only have to hit it for a few seconds until the solder melts. Because the rest of the board is already heated. So, Scodomodo, the developer of the eSpeed Pixel Stick version 4 firmware, is also getting brain boards. But he's already been working on that for the Dig Quad and the Dig Uno, for instance. But yes, that software will be able to take advantage of the micro SD slot that's on the board. Dr. Roscoe. I guess I should have pulled out those input fuses too. No need to heat those up. Can I still touch this? Yes. Oh no. Can I do it like that? Yeah. Okay. So, yeah, it's going to take a while because it's not flat on the plate. Is there in the silk screen also a max I out? So in total, you're allowed to have 50 amps continuous running through the board. Peak, you can go much higher, that's no problem. And per output, as it says here, you're allowed to do about 10 amps or so. It says max fuse 10 amp. You can put a 15 amp fuse in there, but that's just to denote that basically you shouldn't run more than 10 amp on a single output. Now, if you take a look at 5 volt LED strip, for instance, that uses about 4 amps on an edge connection. So that's why there's 5 amp fuses in there, and about 8 to 9 amps on the middle connection. So that's why I generally use 5 or 10 amp fuses. Okay, let's start with this guy here on the side and see if we can get that to desolder. Oh god, my hot air iron is stuck through all kinds of cables. Hold on. Okay, I managed to free it. So I'm gonna hit it. Oh god, I can already see the fuse terminal bubbling. It might look like I'm not pointing at it, but it's at an angle, so... Okay, I'm gonna turn on my fume extractor too in a minute, because I can smell the fuse terminal. Or the fuse holder. And the socket is melting. No, I don't have an even... This is the smallest tip. And it's also massively linked to all the copper planes on there, so this is gonna suck. Well, no, it's hard to see on camera, but you can see it already starting to melt over here. Yeah, the socket is also melting. Okay, maybe hot air isn't the way. Yeah, it's going to be basically impossible to desolder those sockets. It's coming. Wow, the terminal's bubbling. Yeah, this isn't even loose yet, and the rest is getting destroyed. Okay, so that didn't work. Well, I think upping the temperature is a good idea. So let's go to... I don't dare go above 180 because stuff will start melting. Yeah, Skodo, I upped the heat plate from 100 to 180. So let's see what that does. I get it, Leon, but the terminal is also melting, so then I also have to remove those. And this is a 4-layer board, and even though I have a desoldering gun, it's meant to distribute heat and power as efficiently as possible. That's how I designed it. So it's basically going to be almost impossible to do that. So I think our best bet is to really heat it up from the bottom and, you know, then hit it with a little bit of extra warmth to get those off. Okay, I put the plate on 180. I have multiple of these, but not that many. So I can destroy one, that's fine. But if I destroy all of them, that would suck. Because I want to do testing on them. And, you know. Yeah, let me turn the hot air off. There we go. Let me get the flux out, because that is a good idea. But it's gonna be hard time anyway. Yeah, I do have Captain tape, which could protect them. Oh, where's my needle? Hold on, I need to get a new needle for my flux. So the heat blade is at 150 now. Okay, let's see. So let's put a little bit of flux on there. Problem is it will immediately start melting, I think. Okay. Let's do it like that. Yeah. Yeah, I have Captain tape. We can try that. It's going to be tedious though, because I probably should have done that before I put the board on the heating plate. But, you know, I'm just going to heat it up to 200, because it's not going to become 200 because it's not flat on the heating plate. We're at 167 right now. Oh, DJ Roscoe, tin foil would stop the direct heat, but it would still transfer the heat. Kapton tape would work better in that regard, or maybe some silicon shim or something like that, but... So, for the new folks, just to reiterate, there's nothing wrong with the design, or at least not that I know of so far. This is went wrong during manufacturing, and that is exactly why we do these pre-production runs, to figure out these issues before we do a big production run. Okay, heat plate's at 179. I guess now we wait. Does anybody have any questions? 180. Oh, wait. Well, we're at 189 already. But yeah. Dremel it off. Huh. If it wasn't a surface mount component, that would have actually been a very good option. And I do have these diodes in stock, so that's not a problem. Yeah. No, 188. Sorry, Nicholas. Now, this is just a power board. So, in the end, it'll combine with a brain board, which you can see on top here. If it focuses, no, doesn't want to. There. So that's a brain board on top of a power board, and that will make it a complete controller. So the power board itself is just for power distribution. The brain board is just for input, like network and stuff like that, and LED output, and together they form a LED controller. And thus you can scale the resource you need instead of having to use data ports for power injection, or just not having more power injection ports, etc., or more power available. There is no 5V EXT on these boards, but all three power input methods, so Q power post, the 2-pin, and USB-C, are allowed to have different voltages and are allowed to be connected at the same time. So you can have a 12V power board connected with Q power post to a brain board feeding that power, while also having USB-C, for instance, with 5V for standby power. Because then you can have a relay on your power board power supply, and the brain board will stay alive with its 5V USB-C. So you can have varying voltages, all the power types connected at the same time. It's all fine. Jordy, in theory, yes, I could remove them. But if I can remove them, I can also fix them. I'm going to try and get my... Sorry if this creates extra noise. So, well, now we can see chat anymore. Oh, Jesus. My desk is too small. But yeah, these are for testing. So if I can't test, it doesn't make too much sense. Okay, I need to move my chat somewhere else now. Let me move it here. There. Can the USB-C be connected for a PC for debugging purposes on the flash software? Yes, but you'll have to deconfigure some of the pins. But if you don't use that LED channel at that moment, then you can debug and do stuff like that. So if you blow them up, they won't work. But if they are in series with the connector, there won't be power at that connector. I'm not sure what you're referring to, Jordy. You're going to blow all the fuses at the same time? Wow. No, that's going to be very hard. WLED or ESP pixel stick. Yeah. Manny Luca, I am from the Netherlands. And Nicholas, yes, the whiteboard can run WLED. That's actually what we had on there right now. We tested that a little bit earlier in the stream. Okay, so it's at 196 now, and I can definitely smell it. They are used as reversed polarity protection, so that in the case you connect something wrongly, in theory, the diode should shunt the power away and blow the appropriate fuse, trying to protect whatever you have connected there. Can you control with the temperature sensor on the brain board a fan? What is the normal purpose of this sensor? You can't control the fan directly, although you could use the relay output and then connect a fan to a relay and then turn it on and off based on software controlling the relay if you really wanted to. But other than that, the temperature sensor is there if you want to measure the temperature inside of your box that you have the controller mounted, basically. The smell of burning PCBs. Okay, so let's give that another try. So I've set my heat gun to 380, and the heating plate is now at 200. It says it at 198, but that's close enough. Let's try and hit that same diode again and see if we can make it work. I can still touch these terminals. Oh yeah, the cap is hot. That's for sure. Okay, the heat gun should be at temperature now. So let's... What is it doing? Okay. So let's hit it. There is flux on there. And I just want to turn it around. Okay, the flux is smoking. That's fine. That's what it's supposed to do. And it just won't budge. There is a molten fuse socket on my tweezers. Okay, my tweezers are getting too hot. Problem also is this is soldered with leadless solder, so it needs really high temperatures to... Yeah, it's not budging at all. That terminal is getting destroyed. Okay, I'm gonna hold it on there for a little bit longer, but I don't know, man. Oh, it's budging. It's starting to budge. Yeah, but the fuse holder is also starting to melt over the diode. Oh, I got it. Okay, I got it, but I don't know if anything survived because there's plastic everywhere. Let me turn this off. I think we're gonna try the soldering iron next. Yeah, it's wrecked. It's totally wrecked. Let me, I mean... That's not looking great. Let me try and clean my tweezers of all the plastic that's on there now. Oh god, it's gunked on. Of course, the plastic cooled down now. So now I just have plastic tweezers. I mean... They're not supposed to be black. Yeah, I'm gonna try soldering iron next. Yeah, that fuse holder is destroyed. And I'm not even 100% sure the diode's on correctly now, because I couldn't see anymore. Well, I want to test these boards, Philip. I don't want to delay for another few weeks, because these are on in reverse. It'll be fixed in final production, but, you know... Let me get a magnifying glass. Can't actually see. Okay. It's on in the correct order. And I think it's sticking inside of the solder. Reverse the power instead. That's gonna be hard. Okay, so next idea is not hot air, but use my soldering iron. So let's get that out. Of course, it's all tangled up too. What the? How did this even happen? Hold on, I have to wrestle with tied up wires on my desk here. Okay. Okay, hold on. Turn off. Yes, thank you. All the wires got tangled, so I have to untangle them, because otherwise that's going to be really annoying. Oh, come on. It's already annoying. So, should I go in with a big tip, and thus a lot of heat instantly, or a small tip? What do you guys think? Okay, that's unfurled. Wow, that plate's hot. Okay. Let's turn this back on again. Okay. Try first not to hit. Try small first not to hit anything. Yeah, I think I agree with that. I'll try my second smallest tip, not the absolute smallest, because that's for very small stuff. What's going on here? Okay. So let me put that tip on. Okay. Yeah, I guess we're going to try that second one. Oh, you can see the polarity good now. That's nice. Okay. I guess we're going to put some flux on there. There we go. And so, okay, let's take the iron. But the problem is we're going to have to hit two sides. Oh, you can see it glow. It glowed for a second. Oh, wow, it overshot to 450 degrees. Okay, that's bad. Oh, well. So let's hit this side. And then hit this side. Yeah, I'm already melting the fuse socket here. This was never meant to come off. That's also a difference between a production design and a DIY design. On a DIY design, I wouldn't have spaced it this closely. Yeah, I'm melting into that fuse socket. No, I didn't forget flux. I put flux on there. Yeah, this isn't working. Because there's so much copper. The second I let go, it's basically melted back solid. I need to add some solder first. Sure, I can do that. But I basically can't reach the pad without melting the fuse socket. Oh, I know what I can do. That's probably going to be the trick here. Let me, what I have is I have low temp solder paste. So I have the 138 degree stuff. So probably if I add some low temp solder paste, which is actually lower temp than the heat plate is right now. Well, yeah, it's not about looks for this board, Emil, so that's fine. But if I add the 138 degree paste, in theory, because the heat plate is at 200 degrees, it'll almost melt. Who said the low solder paste first? Or low solder temp? I don't have any tin, but I do have paste. I think Savok said if I have some solder to add. No, you can't remove those. Those are integrated. Yeah, that's a good idea, Wayland, and others that said it too. That's a good idea. That's likely going to work. Well, we're going to see if that works, but so let's add a bit of paste here and a bit of paste there. And let's do it for the next one too. Well, that was a bit much. But in theory, that is 138 degree paste. So let's hit it with the soldering iron again. Okay, that makes it dry up. That's good. And then on this side, a little bit more on that side. This side, that side, this side, that side. But still, there's a lot of mass there. Okay, I'm gonna up the heat plate to, I don't know, 250. Because if that solder isn't melting on its own, that means the board isn't at 138 degrees yet. Yeah, I do that normally, Philip, but this wasn't meant for DIY. And if you use the constraints of DIY, a lot less is possible. Oh, look at that one. It's starting to solder. See that? So in theory, can I move it? Not yet. Okay, this one came off. Don't think I ripped the pad. That's good. Let me try and reach it. I don't know if there's actually solder there, but we'll see. So let's see if the other one is just loose now. No, it's not, but it's still rising in temperature. So let me add solder to another one. That's starting to bubble. Some of the cult boards, some of the green connectors can pop off. Yeah, but those aren't side connectors. Those are top connectors, so that's probably different. Okay, let's see if we can move it already. No. Let's see if this one... Oh, stupid me. Let me try and tack this down. Oh, come on. I need some tin. Now, I knew this was going to be hard from the start, but yeah. Well, maybe I shouldn't have used tin with paste. Oh man. Okay, hold on. Okay, that's on there. It's not pretty, but it's on there. Let's see about these. So this is fluid, but this side isn't. Oh man, that fuse holder is getting destroyed. Why aren't you coming loose? Okay. Yeah, that's true, Andy, but I'm gonna try and hit it with some more low temp and then use the heat gun. So more low temp for you guys. More low temp for that guy. No more using solder wire because that's high temp. Okay, let's use the hot air. Yeah, this doesn't look good for the quality, does it? Don't worry, boards like this don't get sold to anyone. And I mean, the fuse holder's plastic is just that. It's plastic. You don't technically even need it, but yeah. So let's wait for the hot air gun to warm up a little bit. And I'm hoping I can just blast it and it'll instantly come loose. Exactly, Philip. Okay, so let's see. I think we're working on this one. Well, it's not instantly coming loose. Oh, come on. Oh, no. Oh, no. No. Yeah. No, that's not going to work either. Oh, man. Okay, hold on. Hold on, let me turn this off. I need to clean my tweezers. And there's a diode stuck in there somewhere. Yeah, the diode is fused with the fuse holder. Oh, man. Okay. Okay, we're going to up the temperature to 300 degrees. Okay, the heat plate's now set to 300 degrees. Which, in theory, it's 138 degrees paste. So, you know. Melt it all! Carnage! Yeah! I knew this was going to be hard. But this is kind of getting problematic here. So let's hope that with the heat plate set to 300, it'll actually melt the low melt solder. Which it seems to be doing. I mean, that's soldering. Right? That ball is staying liquid. So let's see. But why is this still stuck? I mean, I can move the whole board with it. Doesn't make sense. This ball is liquid. Should I kind of rub it in there a little bit? Really get it into the joints? I mean, this solder is liquid. You can see that, right? Well, it's still rising. It's, yeah, Mr. Dasuhiro. I'm not sure about that because there's so little room to reach. Basically, I'm now dousing it with paste, which is low temperature paste. And I don't have low temperature solder tin. So, no, there shouldn't be anything other than solder holding that diode down. But it is made with production grade high temperature leadless solder. So I was hoping that adding the low temp solder, like some really smartly suggested, would actually fix that, but it's just stuck on there. But it's still rising. We're almost at 300. I guess I can destroy the diode. I mean, keeping those big caps on there at 300 degrees all the time is a very bad plan also. Let me maybe put on my safety glasses. You know, just to be safe. No, I don't think I can. If I already have issues removing these diodes, I don't think I can remove those fuse holders. They're soldered on with way more surface area than that, so yeah. I mean, this is as fluid as it can get. It's creeping back to the pad like it should. Sure, you can go into that pad, that's fine too. Oh, I got it. Okay, so I just have to turn it around. Okay, that's done. So that is for sure the best method till now. So I just need to make sure this solder is like massaged in there, or what's the idea? One fuse holder at least survived the surgery. Cut it in half and then solder on top. No, because the pads are only on the bottom. That's going to be very hard. So maybe just douse it in low temp solder. Maybe there's too much high temp still remaining. Let's do the next one too. I'll move this over a little bit. There we go. Maybe I can hit it with the soldering iron, which will make the low temp and the high temp flow together better. And there we go. Interesting. So now it's loose. Well, it doesn't need to be flat. I don't care about it being flat. Okay, so that's another one done. So let's try it with this one too. So we hit it with the soldering iron. And then over here too. And then it comes loose. And now we can just move it. Yeah, there's way too much solder on that one, but that's okay. Cool, okay, so that is the way to do it. So let's do it for another two. So, low temp solder paste. Let's spread that around a little bit to make sure it goes where it needs to go. And then hit it with the soldering iron. And it comes loose. Wow. Yep. That's the way to do it. Yep. Nice. Thanks, guys. It would have probably taken me longer to figure that out without you guys. So there's 4 left. I'm actually going to use my screen. Oh no, don't put it in the socket. Oh wow, this one's very tight. Okay, I'm gonna need to turn it. Hold on. There. Because otherwise I can't see. Well, all I can say is, welcome to real life. You guys thought I was some kind of soldering wizard. Turns out, I'm not. I'm not bad at it. But, you know. That's loose. Oh no, no, my cable's stuck. Okay. This is gonna be difficult. Okay. Yeah, I can't do it another way than touching the terminal or the fuse holder. Okay, it's loose. Let me get the plastic off. Later, Emil. Okay, that's loose. Oh man, I have to dig into the plastic. Well, that one's a mess. No, the smell is horrible. Okay, let me add some more solder over here. Okay, loose. How to solder plastic. Yeah. Okay, in theory, I should now be able to turn these around. That's one. That's two. Sorry I can't show you any better. That's three. And that's four. So now, man, we have to check if all of them are indeed in the correct order or in the correct position. Is it back? And is it working? Let me know if it's back and working. Ah, okay, nice. Okay, so what maybe the issue is, this capsule was hanging over the heat plate. So maybe the condenser capsule or whatever got too warm, which influences some resistance or whatever. So I don't know. I'll have to listen that back, because over here everything looked normal. So I turned the heat plate off just now. It became kind of a mess, but in theory it should be fixed. And the other diodes are correct. He killed the chipmunk. Yeah. Okay, let me try and get the board off of the heat plate, because otherwise it's going to take a long time. Pliers. There we go. Hold on just a second here. I know you can't see. Okay. Transfer successful. Well, there's nothing to see right now. There's just a heat plate, and I moved the board off of it. Okay, so let's give that a little bit of time to cool down. Sorry, I didn't notice. That is one great mic. You want me to recreate the issue? I have no idea what happened. I'll listen it back later when all of this is done. But yeah. Whoever donated to let me know the audio was broken, thank you very much. Oh, it was Philip. Thanks, Philip. I have no idea what happened. Maybe because of, as I said, the microphone capsule warming up. It's never happened before. Just trying to clean this plastic crap off of my tweezers. Best stream ever! No matter what comes after this. Thanks, Andy. No, I'll listen back to it later. That's fine. I don't understand. Okay, I think I managed to clean off the tweezers pretty decently. I need a drink. There's so much plastic smoke in my throat and lungs right now. Yeah. But one thing that will come out of this, even though this board is kind of destroyed, functionally, I think it'll work just fine. But visibly, it's destroyed. I should have two more. Donald Duck is talking. Thanks, Savak. You want to see a live reaction? Okay. I think I can do that. Hold on. Let me open another type of browser. And let me open my own stream. Okay, minus 8 minutes. What the? What's going? Why? Let me turn that up. Hold on. What? When did it start? What's even going on? It's like a Donald Duck that's pulsing in and out. Okay, okay, okay. I had no idea what I was saying. Right, okay. When you move the hot plate, yeah, maybe the capsule got too warm or something. I don't know. Super weird. I don't know if this one tops the silicon tube yet. Maybe I should have gotten the girlfriend to help me desolder, desolder those diodes. But yeah, the trick was low temp paste. That was definitely the trick. And then melting the pastes together, because even though the low temp was on top of the high temp paste, the high temp still didn't melt, even though the low temp wasn't on there. Kind of makes sense. So then you have to hit it with the soldering iron to make sure that the hot temp paste melts and then mixes with the low temp paste, and then you can you can move it. Sure, I think we can do diode testing. Sure, we have a very nice new multimeter for that. Let me set that up while all of this cools down. I think I need that one. And then I need this one. I'm gonna do some cleaning up first. I mean, I'm kind of knackered. Did these LEDs fail? No. No, I'm in a garage. It's big enough here, Philip, but thanks. Let me clean up my soldering paste and flux here real quick. I just need a minute to relax, sorry. But it's good, even though this board is kind of half-wrecked. At least I now know how to do it on another board. That's kind of how life goes, right? You try and figure out how things work, and then you know how it works. And next time I need to desolder something that's soldered in a factory, I know to add low temp paste. That was a very good suggestion. I keep solder paste in the fridge, but only the solder paste which requires to be kept in the fridge. And this is low temp solder paste from Chip Quick, and well, it doesn't require that. So that's why I don't keep it in the fridge, because then it's easy to use. But it is also hella expensive stuff. One of these little tubes will cost you 15 to 20 euros. But I like prototyping with it to prevent this kind of situation where if I need to change or move a component, well, I can just do so because it's all low temp paste. And then the production models, of course, get made with high temp paste, but yeah. I didn't think about trying to change the production model. So you use 10 euro of solder paste to wreck the board? No. Yeah, some paste does need to be kept in the fridge. I mean, yeah. Just not this stuff. Please do it again next stream. I don't know what caused it, so I don't know if I can. So let's take a look at the bottom of the board. Still warm. Yeah, nothing here melted. So even with the hot plate set to 300 degrees, it still didn't melt this solder. And these are some neat joints. Oh, right now I am drinking Coca-Cola Zero Sugar Vanilla. Right, I was busy with the multimeter. I can't get my probes. Oh, such a mess here. Okay. Well, it's actually too small, but you know. Okay. Too much equipment, too little space. Let's put my soldering iron back. Okay. And I can turn this off now. Ah, such quiet. Nice. This can move back. Okay. Because then we can zoom in on here. I mean, the factory did a nice job soldering. I mean, if you look at these joints, these are perfect. Right? Those are awesome. But then, if you look at the other side of the board, you can see total carnage and mayhem. It's absolutely destroyed. This fuse terminal, this fuse holder here just has the side burned off. Will it still take a fuse? Oh yeah, no problem there. I mean, you can say that, Philip, but normally it shouldn't matter. Okay, I can touch the board now, so that's good. Let me start my my multimeter software. And in theory, yeah. So let's connect to my multimeter. Okay. Yeah, that's working. Nice. Let's go to diode measurement mode. Okay. And let's oh wait. Sure, that works. And let's measure it. Okay, that's open, that's correct. And this should be closed. And it is. And same for this guy, if I can reach it. Yep. So let me measure a known good. So this here is a known good diode because we didn't touch it. And if I measure the non-blocked versus the blocked, the positive can flow to the negative. That's good. And the negative, but if we do it in reverse, it can flow, but it will have a bit of voltage drop, right? So that's correct. So let's measure these again, and let's measure the voltage drop, because this is the same type of diode, and we're seeing 0.18 volts drop. Okay, let's measure this guy. 0.18, that's good. Let's measure this guy. 0.18. Well, there's no diode here, so there's... Oh! if I now measure this terminal here, the LED turns on. So it should over... Yeah, does here too. Cool. Okay, sure. And let's measure this guy. $0.19? Sure, that's fine. Yep. 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 Wow, this is destroyed. Okay. Yep. Oh wait, I can actually do it easier. I can just touch here. Yep. Yep. Actually, that's better, because then I check... Yep. Check that all the solder joints are good, basically. So in theory, I should also be able to... Oh, right. I can do it like that. So let's do the checks again. I'll put the positive on ground, and then the negative on the positive pin. That's the reverse that it should flow, but that's the only way we can measure the voltage drop over the diode. And now if we touch here, touch here, touch here, touch here, we can measure that all these diodes are basically okay. Except for the sockets which don't have a diode. There the LED starts burning, which is also correct. But this means that we fixed all the diodes and all the solder connections are proper. Well, not proper, but there is a formal solder connection there. Holy shit. So, are we just going to mount a brainboard on top of it? Just for the heck of it? Yeah, let's do that. Proper, yeah. Sometimes it might be more plastic than solder, but, you know. 60 watching, 6 likes. Everyone's just mesmerized by what's going on. Okay, let me put the input fuses back. Okay, let's, I don't know, let's put all the fuses back. In theory, it should be no problem that those diodes are missing, actually. So we're just going to connect everything. It just means the reverse polarity protection and stuff like that is going to function a little bit less well. I'm gonna trigger people by not watching which way the numbers are put in. Yeah, but especially for this purpose, 0.18, 19, or 0.20, that's fine. There we go. Oh wait, I need to turn these two around. Yeah, exactly, Andy. With the fuses in, you almost can't see that this board is completely borked now. Yeah, I use KiCad for everything. Yeah, let's just put a brainboard on. Might cost me a brainboard, but we'll see. We'll see. Let's get a new one. Of course, we don't know if that one's known good, but we'll see. So, brainboard. Blamp. There we go. Done. No. I need to get a brainboard baggie, which is not this one. I think it's one of these. Is it? Yes. Good. Okay. Yeah, I'm just gonna do it. So I need the same as I used last time. And that is these 5. And then I need all the screws. And don't need the rest. Don't worry, I'll have articles explaining what all the standoffs are for and how to mount it in which order and things like that. Okay. I find it easiest to stick the screw through and then just thread the standoff on. Doesn't have to be overly tight, just finger tight is fine. Oh, I guess we should put standoffs on the board too. Yeah, there's no article for that, Philip. Sorry. Okay, last one. So what do you guys think? Is doing these standoffs easy enough for the end user, you think, who are going to use this type of board? Generally, you'll be a slightly more experienced person than using a Dig Uno or a Dig Quad, I'd say. Okay, these are nice and finger tight. Let's put the brainboard on. Oh, this one doesn't wiggle. Yeah, no article for that, Philip, sorry. Thanks, Savak. I try. The hardest thing often is finding the right article. But if you're good at searching on my website, you might already find lots of articles for the Dig Octa, which I've been working on. The ground labels are just copper, yeah. But they are actually ground. So the labels themselves are also ground. Don't make a ground label that isn't ground. You say that, Andy, but I've had boards in my hands where they have metal labels like I like to do too, where it said ground, but it certainly wasn't ground. I think that's a big no-no, but, you know, somebody else designed it. So, okay, yeah, that's on there. Good. I think we're just gonna go for it. Right, so let's get power. Let's get my Coke out of the way. Oh, and I was so smart to already put in all of the fuses. Oh well. So, positive power. Negative power. And we're going to turn it off on without LEDs first. Or no, we're just going to go for it. We're just going to connect LEDs immediately. Okay. Oh, where's that plug? Oh, that plug is in the other one. Okay. So let me add this plug here. I didn't put standoffs on the power board. In theory, this desk won't short anything. Let's leave it. Okay. Okay. We got a bar. We gotta get a bar. And okay. Let's wire up data. If I can find my screwdriver. Does this one work? Oh, it does actually. Nice. Or it did and then didn't. Okay. Where is my small screwdriver? Here. No, this is the wrong one. Oh, here it is. Okay. Hey, Maiko. Well, you missed some destruction of PCB boards. Okay, let's get a pluggable connector. And let's pay attention to what is positive and negative. The side where the fuse is positive, and the side where it says ground and it's white, that's the negative. And again, we have Phillips heads. Okay. Are we gonna go for like the utmost destroyed one? Of course we are. Let's go for the oh wow. The connector doesn't even fit anymore. Look at that burn here. Okay, I'm just gonna jam the connector in there. There we go. That should be fine. Let's get some Ethernet. And I don't know if this one's flashed or not. We're gonna see. Oh, I need the power cable from this guy, which is still really hot. Okay. Turning on the power supply. Let's not set it to 5 amps. Let's go for 1 amp again. Okay, positive on the positive side, negative on the negative side. We have an output connected here, positive, negative. We have a data cable. Okay. Should I put on my glasses? Hold on. Okay. Just to be safe, you know. On. Okay. Seems to be... Oh! It's doing the random color thing again. Does the Ethernet work? No. Interesting. But I don't know what firmware is on here, so who knows. I guess we should flash it then, huh? Not sure why the Ethernet's not... In theory, it should have Ethernet firmware, I think. Oh, there we go. I'm not sure why that wasn't working before. That's fine. So, let's see which IP this got. Okay. Let's turn off the multimeter stuff for now. Let's turn off these glasses. Okay, I know the IP. Okay. There. Okay, so this is the one that we just connected to. We have 100% signal. We can do refreshes and stuff. So let's reconfigure that the same we did the other one. We turn off the brightness limiter. We go to SK6812. And we set it to 144 LEDs. Save. Oh, interesting. Oh, wait. I was going to be like, you can't see it on screen. You can see this LED flickering a little bit. But somehow it failed. I was like, wait, why did it fail? That's because we're still limiting at 1 amp. So let's give it 5 amps. There we go. Let's see if it boots back up. You can do it. No, it can't do it. Okay, let's reset it. Okay, let's turn off power real quick. Okay, it looks like it just needed a full refresh. Power off, power on. Now it seems to be working fine. Okay, so now we can change the color. And in theory, we can also do an effect. Yep. Nice. That is working perfectly. Awesome. Yeah, the blue LED is too bright. I fully agree with that, but that will be fixed in the actual production, and this is the pre-production. So I mean this, yeah, so this is one of the load bars we built in a prior live stream, but it has a curved back here and a flat surface here, so that's why the LED strip is on that point. Okay, color waves. But that does mean we fixed everything on this power board, because if we didn't, well, it would basically instantly short out the power supply. So, I mean, I didn't know if this was going to work, because I knew it was going to be a beep trying to get those diodes reversed on there. So, I'm actually really happy we were able to fix this. And let me see if the broken fuse indicator still works. In theory, it should now. So, yeah, there we go. Nice. Those are meant to be that bright. But as you can see now, you have a broken fuse indicator, which is closest to that port. It was hard to get it somewhere else on the board. But that works great. Cool. Nice. Awesome. I'm really, really happy with that. Because you know, this was the test to verify if these boards even work. I mean, I had my prototypes and, you know, I know those work, but who knows, maybe there were more mistakes on there or out of spec parts or, you know, and I'm going to do lots more testing, but I'm really happy to see this work. That is awesome. Yep. Nice. Oh yeah, I know, Andy. I know. And you're getting boards where the diodes is already fixed. So, but that's why shipment slipped from this week to next week. Yeah, thanks Arthur, and thanks Savak and Maiko. That was difficult. But now that I know how to do it, I can take one of the other Power 5s I have and fix it with much less damage than on this one. I don't know how they'll fix it. They can't throw it away, because if I have to order the PCBs again, they'll cost me $400 or $500, and then all the parts again. No, actually more. And then all the parts again, another few $100, and then they have to assemble it again. They do that for free because they effed it up. But I mean, I'm still out like $700-800, and 2 to 3 weeks of time, which I don't really have to spare anymore if I want to have this available at the end of September. So, no, they're not going to throw it away. They will fix it. And I don't care how they do it. They'll likely use almost the same method as I'm doing. But then again, if they screw up the terminals like I just did, we're not going to accept that either. So, no, they can't print new boards. Absolutely not. We have different companies for PCBs, assembly. We do testing in-house. We do flashing in-house. We do component sourcing in-house, but we have several component suppliers. It's a whole chain. Yeah, but no, if you grow big enough, PCBWay and JLC PCB do so in-house, but it's still different plants and actually different geographical locations where they do that. They don't do that in the same building, basically. So, even though it seems like an integrated service, in the back end, it's all separate things. But yeah. Ultrasonic stuff to not damage the fuse holders? I don't know. Can you do ultrasonic soldering? I don't know. I mean, it's no problem that now the diodes have low solder paste if they use the same solution for my pre-production boards. I don't have a problem with that because in theory they won't get hot, but yeah. Well, maybe they do magic. I mean, I've seen their soldering jobs, also their manual jobs. I can't do that. I don't have their precision or equipment or whatever they do, but they do excellent work. Well, they should have done it overnight last night, because we kind of demanded that. But they said they couldn't finish in time. So, there were some very stressful people working on this. Probably the ones that effed it up. I know ultrasonic welding for like plastic cases and stuff like that, because we evaluated that for the dig to go, but we went with a snap case design instead. But I've never heard of ultrasonic soldering. But yeah. Now I get why my boards are taking longer. Yeah. Well, you know, I want to make sure things are right. That's why I pay like a few $1,000s on a pre-production batch, so that this kind of shit doesn't happen to things I actually deliver to customers. And, you know, it's a lot of money. But that kind of happens when you want to do it right. It's expensive. This is not something you throw together by JLC PCB and, you know. Yeah. Oh man, this fuse holder is like totally trashed. I mean, nothing's left. These are okay because I did the new method there. But this guy too is like plastic sticking everywhere. Yeah. Anyway. So in theory, I can now also take this plug and, I don't know, plug it in this one. Yeah. Is this one without a diode? No. Yeah, actually it is. And this one? Yeah. Still works. It doesn't need a diode for normal function. It does need it for reverse polarity and stuff. Quinder is a multi-canner. Oh yeah. Well, we've been going for almost 3 hours. 2 hours, 59 minutes, and 30 seconds. I am so ecstatic that this now works. And it works, you know, it even works at all. I mean, you spend a few $1,000s and you pray it works. And you know, if you know me, you know I do a lot of testing and verification and testing it again and making sure it works right. But, you know, it can always be something. Oh, you got work tomorrow. Okay. Well, let's do a last test. And, oh, I was going to reveal the prices, right? So let's do a quick last test. And the last test will be, I'm going to insert USB-C while it's on. I hear the beep beep, so it's connected to serial and stuff like that. Now let's turn it off, the power supply. Board is still on. Okay. And now let's turn the power supply back on. Ha ha ha! And the LEDs are still going. So you can actually use a simple USB-C charger, and it's officially USB-C compliant to have standby power on a brainboard. The best stream ever! Yeah, so price-wise, and you can actually leave this connected at the same time, that's no problem. That's all protected circuits and stuff like that. So, price-wise, a brainboard is currently set at $32.50. So that's slightly more than a Dig Uno. Well, maybe not with Ethernet on there, actually. I think an Ethernet Dig Uno is still more expensive. But it's certainly less than a Dig Quad, also with Ethernet. So $32.50 for a brainboard, which will get you Ethernet, SD card, external antenna, button inputs, temperature sensor, although it's still debating if I need to include that one or not. 8 LED channels, etc. So that is a good price, and that is because unlike bigger solutions, like a Cult board or a Falcon board, etc., those can do like 48 outputs, and then each output can have 600 to 800 LEDs. An ESP32 can't do that. And with WLED, you're kind of limited to 1,500 to 2,000 LEDs in total. ESP Pixel Stick, you might be able to do 3,000 because it's a bit more lean, so a bit more efficient. But there are certainly limits. And so you can't fill up all those 8 ports with 800 LEDs and drive all of those with a decent frame rate. However, you can use 8 ports and, for instance, have 100 LEDs per port, so you can run a separate data cable to each prop instead of having to daisy chain, for instance. So there's still lots of uses for that. It's just a different system. And if you need more ports or you need more total LEDs that you can drive, you just add on a brainboard, which will be another $32.50. But if you, for instance, used a Power 7, you'd already have 16 power ports, and then you'd also have 16 LED channels, and doubling the total amount of LEDs you can drive. Now that's less useful if you use it for WLED. You can use the sync feature, but you can't really use it as a whole. But if you're driving Christmas lights, you're likely using external data, either using the SD card or using the Ethernet socket, and then it basically just scales, because it doesn't matter in X-Lights if you have one controller with 32 ports or if you have 4 controllers with 8 ports each. So now you can just buy the amount of LEDs you want to drive and ports you need to have in brain boards and stack those on top. And well, those are $32.50 a piece. Current pricing for the power boards, I don't actually know from head. I believe the Power 5 is going to be about $25. The Power 7 is going to be, I believe, around $29 to $30, and then a Power 7 HC, so the high current version, which is a lot more expensive to manufacture, I believe is going to be $35. But in theory, you should be able to get a Power 7 with 2 brain boards on top for about $100, which will give you 3,000 LEDs in total, 16 data ports, and 16 LED channels, basically. Yeah, exactly, Andy. That's the idea. You can scale whatever resource you need. Because if you're running 5-volt LEDs and you need a lot more power, but you don't necessarily need more data ports, you just add a power board. And you don't have to waste output sockets that have power and data combined, like on most other boards, to do power injection, or you have to get a separate board for it or whatever. You just scale the solution however you need it. So yeah, $32.50, I believe 25, about 30, and then the HC version is about 35, I believe. For the chipmunk feature, that's priceless. Can't tell you how to do that. So Savok thinks it's decent, good prices. What do other guys think? You know me, I try to offer it for the prices that I can, not what I can get for it. So timeline, Randy, is it's slated to release end of September. Maybe it'll slip a few days beyond that, but the end of September date is really what we're striving for. Well, Andy, you're one of the guys that needs to test it, so you're going to help in getting that release date, in finding issues that need to be fixed before then. Thanks, Earth Gamer and Randy. So let's turn off power again. This is basically like a relay turning off power, except we didn't use the relay feature in this case. I have a manual button here. And let's turn on power again. Ha! LED's still going. Awesome. That's because we have the USB-C in here. So that all seems to be working fine too. And this is already the second brain board which seems to be working fine. And now a Power 5 that works fine. Kind of melted, but it's still working. Does that say anything about my robustness of the boards? No, I don't think so. But so let's round it off, because that was an intense stream for me too. It was already warm enough here in the garage, but I really didn't know if that was going to work. But it did. It did. Can I get this out? Yeah. We have a blinking bar. Nice. Blinky blinky. Color waves. Oh, look at that. We got a fire bar. Awesome, awesome. So we repaired this Power 5 And next to that, we talked about a lot of features on the board and how to use it. You saw me assemble 2 stacks completely. So, yeah. No, that's correct, Andy and Ross. There is no relay on the board. It's meant to be used with external relay modules, either solid state or normal clicky relays. Both should work fine. It does have a very robust relay output and always 5 volts. So even if you give it 12 volt or 24 volt, the relay power output will be 5 volt always, just like the relay trigger output. And that's why you don't need 5 volt EXT and stuff like that. Yeah. But you need an external relay module because the idea is that you're going to switch a 50 or 60 or 100 amp external big LED power supply on the AC side while keeping the board alive using the little USB-C feature. So yeah, you'd always need an external relay for that, because otherwise I'd need to have to build a big bulky relay on the board and have AC go through the board and stuff like that. And I don't want that. Yeah, so VEXT and the relay feature works slightly different than on the current boards, where the current boards you need to provide power into the relay terminals and stuff like that. This board just has 3 ways you can power it, and you can use all of those at the same time with different voltages. That's all fine as long as something stays alive when you turn off the big power supply, which likely turns off the power board. And the relay will always get 5 volt power, because the 5 volt will be made by the board. So even if you have a 24 volt standby power supply, the relay output next to the relay trigger output will always be 5 volts. So you can always use a 5 volt relay and that will always work. Can you power the brains by PoE? Sure. Just get one of these, one of these extractor module dongle thingies. You put your cable in here. You either use one of those 2-pin blocks to 2 wires, or you snip this one off, and then you have a PoE powered brain, because you can use that that 2-pin connector right here. So this connector, you just connect this into that, and then the Ethernet into here, and so yeah. So you put the PoE in. Okay. Do you want to see it? Do you want to see it? Let's turn it off. Let's turn it off. Let's turn off standby power. Everything's off. Okay. Let's. Do I want to do it the proper way or the easy way? I'm going to do it the easy way. Okay, this is the last thing we're going to do. This is the last thing we're going to do. So, well. Let me snip off this connector. Okay. And then let me strip that cable. And that reveals a black and red cable. That's good. Okay, I need more. There we go. Now, this is a new one I've been testing. I'm not sure I like it, but we're going to try it anyway, because it does some weird stuff when there's no load. But we'll see. We'll see how it performs. So let's put some ferrules on there, because Sorry, I'm trying to show you, but the heat plate is still on my desk. So that's taking up a lot of space. Okay, so let's snip these wires to put some ferrules on there. No. Yes. Thanks, Savach. Yeah, it's the way I think it should work. I mean, the whole board is the way I think it should work. I'm surprised the camera held out for this long. Because normally, when doing a 3-hour stream, the camera cuts out. But let's see. Okay, let's do these ferrules. Okay. Oh, see you later, Earth Gamer. Okay, so in the bag for the brain board, there is a little orange plug next to all the other plugs for the brain board, because those are all 3.81 millimeter, and the bigger boards use 508 millimeter, or the Power 7 even has 7.62 millimeter screw terminals, so those can accept really big wires. Okay. Now, the marking for what is plus and minus is here in VCC and ground, so, okay. Let's get that into the plug. No, it's not a barrel jack. I used 2-pin because that's more universal, I think. Okay, so plus and minus, let's connect that. And now we have to disconnect Ethernet. Ethernet goes... Okay, let's connect Ethernet. Like that. So now we have power coming in and network coming in. And then we just connect power. Yeah. Let's see here. But I'm not sure I like these adapters. Okay, it powered on because this isn't PoE cable. Network is working. Can I show you that? Yeah, there you see network. Okay, there. PoE on a brain board. So, network with PoE, adapter to make it 12 volt, power input, network input. Done. Let me get my old multimeter. I'll show you. What is going on with my old multimeter? That doesn't seem right. Okay. That's better. I think. Not sure what's going on there. Okay, let's see what power we measure. 12 point... Oh, minus. Oh, yeah, okay. 12.5. That's fine. Sure. Okay. Yeah, it seems like the dial is indeed worn out. Well, I didn't get a new one for nothing. Okay. So yeah, that's how PoE works. If you want to power a brain board with PoE, you get one of these adapters. These are actually the cheapest I could find. They're like $3 or $4. They take in 48 volt official PoE, and they extract that, make it 12 volt for this 2-pin input, and then you can connect network like normal. And if I now turn on the external power supply also, which is 5 volt, we get our LED bar burning, or not burning, but on. And let's do a effect flow. Okay, let me try. Yep. Okay, so you see the flow is running. Let me turn power off, external power. External power is off. LEDs turn off. Board stays on. And I can now turn power on again. And the LEDs are still running because the controller never turned off. So these things are like $3 or $4. I mean, I get everyone wants PoE, but yeah, and if you use a 2-pin you don't have to snip off the cable and do it like that. You can just put a 2-pin adapter on there and then run 2 little wires, I guess. Then this length would also be the same as that length. that should work too. But yeah. No, I cannot do that for $4 on the board. And this might not be an isolated PUE extractor like the more expensive ones are, but for doing stuff like that, I think it's fine. So yeah. So yeah, this works fine. Pew. Oh. Let's turn it on again. No problemo. Controller stayed online. And we also now have a mixed voltage situation, by the way, because the power board is getting 5 volt, but this little input to the brain board is getting 12 volt. But then when there's no power, it runs either off of 5 volt or 12 volt, but it doesn't really matter as long as the brain board's getting 5 volt or 12 volt or both at the same time. It doesn't matter as long as it's getting power. I hope so, Andy. There's a lot of resources and time and thought and money and everything that went into these, so yeah. You didn't know the PUE cable can be safely used in a socket not meant for PUE. Well, no. If you have active PUE, so like official PUE, that's fine, because it negotiates that it wants power or not. If you have passive PUE, it basically just always sends power, and you'll burn out your Ethernet chip if it's not ready to accept power. So that is not always the case, but I have a official PUE, so 802.3 AF or AT switch, which negotiates power before turning power on. So yeah, I have a video about that, about PUE for IP cameras. Look that up, and in there I explain everything between active and passive and different voltages and things like that. So yeah, but this is all official PUE, and then you can do that. Right, so I'm happy with all the feedback because you guys seem to be liking it. Yeah, exactly. Exactly, Maiko. That's why, although it's the same. Oh no, the camera died. I knew it would happen at some point. Well, I was gonna end the stream anyway, so I thank you all very, very much for watching me stumble through this. We made it. It works. It's working. It's doing what it should do. And it's awesome. And so far, all the features we've tested on the board are also working. So that is all great. But exactly, Chris, it's time to end the stream. I'm moving and waving and things. Thank you all for watching. And I hope to see you back in the future. The next few weeks will probably be no live stream because I'm actually going to vacation in the US in about a week's time. But I am stocking up on videos which will be released during that time, including on the Dig Octa board and stuff like that. So, thank you. No secrets. I shared so many secrets today. The whole stream was a secret. Anyway, thank you all for watching. And I hope to hear back from you on the Discord, on the YouTube comments, and in a future live stream. Bye-bye.